Welcome back, everyone. Today, we're going deep, deep, deep into Selenium. So imagine this, you're building a website, right?
Yep.
You spend hours and hours and hours, days even, weeks, meticulously crafting every single thing. Every button, every form, every little detail. But then, the real headache begins. Testing. Manually clicking through every single possible scenario, over and over and over again, on different browsers. Ugh, it's enough to make anyone reach for the aspirin.
Yeah, that's where Selenium swoops in to save the day. It's like having this tireless robot at your disposal, capable of mimicking like all those user actions on your web application, so you don't have to. It's seriously a game changer for web developers and testers.
Oh, robot that does all the boring stuff for us. I am sold. But let's break it down a bit. What exactly is Selenium under the hood?
So at its core, Selenium is an open source framework. Think of it as a set of tools, rules that let you control web browsers programmatically. So you write instructions in a language that Selenium understands, and it translates those instructions into actions on the browser, like clicking buttons, filling out forms, navigating between pages.
Okay, so it's like giving the browser a set of commands, right? A recipe for it to follow. But why is Selenium so popular? I mean, there must be other tools out there, right?
Well, there are, but what makes Selenium really special, it's this open source nature and massive community support. I mean, it's free to use, constantly evolving, and there's just a wealth of resources available online. Plus, it works across, like, a multitude of programming languages in different browsers. You can write your Selenium scripts in Python, Java, C#, so many others, and they'll work on Chrome, Firefox, Safari, you name it.
Wow. Okay, it really is like the ultimate multi-tool for web automation.
Mm-hmm.
But I have to admit, I'm a bit intimidated by the whole programming aspect. Is Selenium only for, like, hardcore coders?
Not at all, not at all. I mean, while you do need some programming knowledge to really get the most out of Selenium, the basics are actually surprisingly approachable. Let's say you're comfortable with Python, for example, which is known for its readability.
Okay, yeah, Python. That rings a bell.
Mm-hmm.
I dabbled in it a bit back in college. So how does Python fit into this whole Selenium puzzle?
Well, Python kind of acts as the bridge between you and Selenium. So you write your automation instructions in Python, and Selenium takes care of communicating those instructions to the browser. Think of Python as the language you use to talk to your Selenium robot.
Got it. So Python's the language, Selenium is the robot. And together, they automate our web testing. Awesome. So where do we even begin? How do we set up this dynamic duo?
All right, so first things first, make sure you have Python installed on your computer. It's a pretty straightforward process. You can just download it from the official Python website. Once you have Python up and running, you'll need to install the Selenium library itself.
Okay, a library. Is that like a collection of pre-written code that we can use?
Exactly. It's like a toolbox, right? Filled with all these ready-made functions and commands that just simplify the whole process of writing your automation scripts. To install the Selenium library, you'll use a package manager called pip. It's like an app store for Python where you can easily download and install different libraries.
So we install Python, then grab the Selenium library from this pip app store. What's the next piece of the puzzle?
Well, we need a way to connect Selenium to the browser we want to control. This is where WebDriver comes in. It's like a special translator that enables Selenium to communicate with different browsers like Chrome, Firefox, or Safari.
So WebDriver acts as the go-between, making sure Selenium's instructions are understood by the browser. It's like having a universal remote control for all your web browsers.
Yeah, that's a great analogy. And you'll need to download a specific WebDriver for the browser you want to use. For instance, if you're working with Chrome, you'll need Chrome driver. You can usually find these web drivers on the official websites of the browser developers.
Okay, so we have Python, the Selenium library, and the right WebDriver for our browser of choice. That feels like a pretty solid foundation. What's next?
All right, so now we need a place to actually write and manage our Selenium scripts, kind of like our digital workshop. This is where integrated development environments come in, or IDEs for short.
Ah, IDEs. I've heard of those. They're like those fancy text editors that programmers use.
Exactly. Popular choices include PyCharm, Eclipse, VS Code. They offer features like code completion, debugging tools, syntax highlighting, which can be incredibly helpful, especially when you're starting out.
So it's like having a super-powered notepad for writing our Selenium code.
Yeah.
I'm starting to see how all these pieces fit together. But before we jump into the actual coding, is there a way to test if our setup is working correctly?
Absolutely. A simple test is to write a short script that opens a specific web page in your chosen browser. If it works, you know you're good to go. It's like a quick confirmation that all the parts are talking to each other.
Oh, that's a great idea. A little hello world for our Selenium setup. So we've laid the groundwork. We've got our tools assembled. Now let's get to the heart of it. How do we actually use Selenium to automate a real test case?
Okay, let's tackle a classic scenario, a web app login. So imagine you have a website with a login page. Testing this login flow manually can be tedious, especially if you have to do it repeatedly on different browsers.
Oh, yeah, I can definitely relate to that. Logging in over and over again just to make sure it's working properly, not exactly the most exciting task. So how does Selenium simplify this whole process?
Well, imagine this. Instead of manually typing in your username and password, clicking the login button, and then checking if you landed on the right page, you could write a Selenium script to do all of that for you automatically.
Ooh, that sounds amazing. Like having a personal assistant just for web testing. But where do we even begin with writing such a script?
All right, so the first step is to tell Python that we want to use the Selenium library. It's like importing a special set of tools into our workshop.
So we're basically saying, hey, Python, we're going to need those Selenium powers for this task.
Exactly. In Python, it's as simple as writing from Selenium import WebDriver. This brings in the core WebDriver module, which is what we'll use to control the browser. We'll also need a couple more lines to import specific functionalities, but we can get to those as we go along.
Okay, so we've imported Selenium.
Mm-hmm.
What's the next step in our login automation journey?
Now comes the exciting part. We need to launch the web browser using our chosen WebDriver. Remember we downloaded Chrome driver earlier? This is where it comes into play. We tell Python to take control of Chrome using this Chrome driver.
So it's like saying, Chrome driver, you're in charge now. Open up a Chrome window and get ready for instructions.
Precisely. And from this point on, we can use Python commands to tell the browser exactly what to do.
Wow, this is incredible. We're talking to the browser through code. What kind of things can we tell it to do?
Well, first, we need to tell the browser which web page to go to. We do this using a command that's essentially saying, hey browser, go to this specific website. Let's say our login page is located at https://example.com/com. We can send the browser directly there.
So it's like giving the browser directions. Go to this address and don't get lost. So we've opened the browser, navigated to the login page. Now, how do we actually interact with the login form itself? How do we tell Selenium to fill in the username and password?
That's where element location comes in. Imagine the web page as a map. Each element on the page, like a text box or a button, has a unique address. Selenium needs to know these addresses to interact with the elements correctly.
So it's like giving Selenium a GPS to navigate the web page and find the right spots. How do we figure out these element addresses?
Selenium provides several ways to locate elements. We can use attributes like ID or name, which are like unique identifiers for each element. It's like every house having a street address.
Oh, okay, so if we know the ID or the name of an element, we can tell Selenium to find it.
Yeah.
But what if these identifiers aren't available? Or what if they change? Is there a backup plan?
Absolutely. For more complex scenarios, we can use something called XPath, which is a powerful way to navigate the structure of a web page and pinpoint elements based on their relationships to other elements. It's like having a family tree for the web page.
XPath, huh? Sounds like a secret weapon for those tricky situations where simple identifiers aren't enough. It's great to have options.
Exactly. Flexibility is one of Selenium's biggest strengths. So let's say we've successfully located the username and password fields on our login page. How do we actually make Selenium type something into those fields?
That's the million-dollar question.
Yeah.
How do we turn our code into action?
We use a command that's essentially saying, type this text into this field. So if we want to enter the username testRzer, we tell Selenium to type that text into the username field we've located.
So it's like sending a message to the web page, telling it what to type. And we can do the same for the password field.
Absolutely. We can tell Selenium to enter any text we want into any text field on the page. It's incredibly powerful.
Wow, we're really taking control of the web page with code. So we've entered the username and password. What's the final step in our login process?
The final act. Clicking the login button. Just like a real user would. We use a simple command that essentially says click this button. And just like that, Selenium simulates a user clicking the login button.
It's like watching magic unfold. We've automated the entire login process with just a few lines of code. But how do we know if the login was actually successful? How do we make sure our robot did its job correctly?
That's a great question, and it brings us to a crucial concept, assertions. Assertions are like checks we put in our code to verify that the results of our actions are what we expect.
Ah, okay. So assertions are like our quality control, making sure everything's working as it should.
Exactly. Let's say we expect the page to display a welcome message after a successful login. We can write an assertion that checks for the presence of that specific text on the page. If the text is there, the assertion passes, meaning the login was successful. If the text is missing, the assertion fails, indicating a potential problem.
So assertions are like our automated judges, delivering the verdict on whether our test passed or failed. That's incredibly useful. But what happens after the test is done? Do we just leave the browser open?
It's important to close the browser window after our test is finished. This not only helps with resource management, but it also ensures a clean slate for the next test we might run.
Makes sense. We wouldn't want a bunch of browser windows just cluttering up our screen. How do we tell Selenium to close the browser?
There's a simple command for that. We tell the WebDriver to quit, and it closes the browser window, ending our Selenium session.
So we've covered a lot of ground already. We've seen how to set up Selenium, how to launch a browser, navigate to a web page, interact with elements, and even make assertions to verify the results. It's amazing how much we can automate with just a few lines of code.
It is, isn't it? And we've only just scratched the surface. There's a whole world of advanced Selenium techniques waiting to be explored. But before we dive into those, let's take a step back and talk about some best practices that can make our Selenium scripts even more robust and efficient.
Okay, so we've seen how Selenium can automate a simple login process. But real-world websites are often, like, way more complex, right? What happens when we're dealing with pages that load content dynamically? You know, like those annoying loading screens.
Mm-hmm.
Or pop-ups that seem to just appear out of nowhere.
Yeah, that's where things can get a little tricky. If your script tries to interact with an element before it's fully loaded, you might run into what we call flaky tests. Tests that sometimes pass, sometimes fail for seemingly no reason. It's like playing whack-a-mole with bugs.
Oh, I've definitely been there. Ugh. It is so frustrating, especially when you just can't pinpoint the cause of the inconsistency. So how do we prevent these flaky tests from driving us crazy?
One of the most important techniques is to use explicit waits. Imagine you're at a restaurant and you've ordered your favorite dish. You wouldn't expect it to appear instantly, right? You'd patiently wait for the chef to prepare it.
Of course. I mean, I wouldn't want them to rush the process and end up with a half-baked meal.
Exactly. Explicit waits in Selenium work in a similar way. They tell your script to pause and wait for a specific condition to be met before proceeding. For example, you can tell Selenium to wait until a certain element is visible or clickable before trying to interact with it. It's like saying, hey, Selenium, hold on a sec. Before you try to click that button, make sure it's actually there and ready to be clicked.
That makes perfect sense. It's like having a built-in patience mechanism for our scripts. So we're basically preventing those impulsive clicks that can lead to flaky tests. Are there any other best practices that can help us write, like, more reliable Selenium scripts?
Another crucial aspect is how we structure our code. As your Selenium scripts grow larger and more complex, it becomes, really essential to keep them organized and maintainable. Think of it like building a house, right? You wouldn't just start throwing bricks together randomly.
Definitely not. I wouldn't want to live in a house built without a plan.
Exactly. In the world of Selenium, a popular approach to structure your code is the page object model, often referred to as PM. It's like creating blueprints for each page of your web application.
Blueprints for web pages. That sounds interesting. Can you break that down a bit for us?
Sure. With POM, you essentially create separate classes for each page of your website. Each class contains all the locators for the elements on that page, as well as the methods for interacting with those elements. It's like having a dedicated toolbox for each room in your house.
Okay, so instead of having all our code jumbled together in one giant script, we separate it based on the page we're automating. It's like organizing our tools into different drawers.
Precisely. This approach makes your code more modular, reusable, and easier to maintain. If something changes on a particular page, you only need to update the code in that specific page object class. Instead of hunting through your entire script, it's a real time saver, especially in larger projects.
POM sounds like a must-have for any serious Selenium project. It's all about working smarter, not harder, right? But even with the best planning and organization, things don't always go smoothly in the world of software development. What happens when our scripts encounter unexpected errors?
That's where the art of graceful exception handling comes in. Think of it like having a backup plan for those unexpected detours in life. Websites can be unpredictable, network issues can happen, and elements might not always behave as expected.
Yeah, it's like those times when your GPS leads you astray, and you have to rely on your instincts to find your way back on track.
That's a great analogy. In Selenium, we use try-except blocks to handle these unexpected situations. We try to execute a certain action, and if an error occurs, we catch that error and handle it gracefully, instead of letting the whole script just crash and burn.
So it's like having a safety net for our code.
Right.
We try our best, and if we stumble, the accept block is there to catch us and prevent a total disaster.
Exactly. It's all about anticipating potential problems and having a plan in place to deal with them. By incorporating graceful exception handling into our scripts, we make them much more robust and reliable.
This is all incredibly valuable. We've talked about explicit weights for handling dynamic elements, the page object model for organizing our code, and try except blocks for gracefully handling errors. What other tips can you share to help us write, like top-notch Selenium scripts?
One more crucial aspect is the art of writing effective assertions. Remember, assertions are the heart of your tests. They verify whether your actions have produced the expected outcome. It's not enough to just automate the actions. We need to make sure those actions are actually doing what we intended.
So assertions are like the judges in our automation courtroom, delivering the final verdict on whether our test passed or failed. So how do we write assertions that are clear, concise, and effective?
The key is to be specific and target the core functionality you're testing. For example, if you're testing a login process, your assertion should focus on verifying that the user is indeed logged in after following the steps.
Right. So instead of just checking if the page title is home, we might want to verify that the user's profile information is displayed, or that a welcome message appears.
Precisely. The more specific and relevant your assertions are, the more confidence you'll have in your test results. Remember, well-crafted assertions are the foundation of reliable automated tests.
This has been a fantastic deep dive into best practices for Selenium. We've covered so much ground, from handling dynamic elements to organizing our code and gracefully handling errors. I feel like I'm already a more confident Selenium user.
That's great to hear. But we're not done yet. Now that we have a solid foundation, let's explore some of the more advanced features that Selenium offers.
Okay, I'm all ears. Let's unlock the full potential of Selenium.
So imagine you've written a comprehensive suite of Selenium tests for your web application. You're excited to run them and see if everything works as expected. But then you realize running these tests sequentially, one after another, could take hours, maybe even days.
Oh no, that sounds like a major bottleneck, especially when we're trying to move fast and iterate quickly.
Exactly. This is where the magic of parallel testing comes in, and Selenium Grid is our secret weapon.
Selenium Grid.
Yeah.
Tell me more. How does it help us overcome this time-consuming challenge?
Well, imagine you have a team of robots, right? Each capable of running your Selenium tests independently. Instead of having one robot execute all the tests, like sequentially, you could divide the tests among the robots and have them run concurrently.
So it's like having a parallel universe where our tests are being executed simultaneously.
Right.
That sounds incredibly efficient.
It is. And Selenium Grid allows you to do just that. It's a powerful tool that lets you distribute your tests across multiple machines or virtual environments, each with its own configuration of browsers and operating systems.
Wow. Okay, so we could have one machine running our tests on Chrome, another running them on Firefox, and maybe even a third running them on Safari, all at the same time.
Exactly. This allows you to test your web application across a wide range of scenarios, much faster than running the tests, one by one. It's a game changer, especially for large projects with comprehensive test suites.
Selenium Grid sounds like a must-have for any team that's serious about web automation. It's all about speed and efficiency.
Yeah.
But beyond parallel testing, are there any other advanced Selenium techniques that can help us level up our automation game?
Absolutely. Think about all the things you do on the web. You upload files, you download documents, you interact with forms, you navigate between pages. Selenium can automate all of these actions and more.
Wait, Selenium can handle file uploads and downloads. That sounds incredibly useful. So many web applications involve these types of interactions.
Exactly. Imagine you're testing a feature that allows users to upload their profile pictures, right? Instead of manually selecting the image file and clicking the upload button every time, you can write a Selenium script that does it for you automatically. You just specify the path to the image file in your code, and Selenium will handle the rest.
Well, that's amazing. It's like having a robot assistant that takes care of all those tedious file-related tasks. And what about downloads? Can Selenium handle those as well?
Of course. You can tell Selenium where to save the downloaded files, or you can even configure it to automatically handle download prompts, making the process completely seamless.
Wow, Selenium is truly a multi-talented tool.
Mm-hmm.
But what about those tricky situations where elements appear and disappear dynamically on the page? How do we handle those moving targets?
Dynamic elements, they can be a bit challenging. But Selenium provides several ways to deal with them. One approach is to use those explicit waits we talked about earlier.
Right. So we can tell Selenium to wait until a specific element appears before trying to interact with it. It's like setting a trap for those elusive elements.
Exactly. And in cases where the element's attributes or position on the page might change, we can use advanced locator strategies like XPath or CSS selector.
XPath and CSS selectors. Those sound familiar. We briefly touched upon them earlier when we were talking about locating elements. Can you refresh our memory on how they work?
Sure. So XPath is a powerful language that allows you to navigate the structure of a web page like a map, Finding elements based on their relationship to other elements is like having a GPS for your web page, guiding you directly to the element you're looking for.
Oh, okay. So we can use XPath to pinpoint elements based on their surroundings or their position within the web page's hierarchy. It's like saying, find the element that's 2 levels deep inside this particular container.
Precisely. And CSS selectors, on the other hand, work by targeting elements based on their style properties, like their class names or their tag names. It's like saying, find all the elements that have the class name button, or all the elements that are paragraph tags.
XPath and CSS selectors sound like powerful tools for those situations where simple identifiers just aren't enough. It's like having a whole arsenal of location techniques at our disposal.
Exactly. And the beauty of Selenium is that it gives you the flexibility to choose the best approach for each situation.
This is incredible. We've gone from automating simple logins to handling dynamic elements, parallel testing, and even file uploads and downloads. Is there anything Selenium can't do?
Well, while Selenium is an incredibly versatile tool, it does have its limitations. One common challenge is dealing with those pesky flaky tests as we talked about earlier. Even with explicit waits and robust locators, sometimes tests can still fail intermittently due to factors beyond our control, like network latency or third-party integrations that just behave unpredictably.
Flaky tests, they're like those persistent weeds in a garden. No matter how hard you try to get rid of them, they always seem to find a way to pop back up.
Yeah, that's a great analogy. Dealing with flaky tests requires a bit of detective work. You need to carefully analyze your tests, identify the potential sources of flakiness, and try to mitigate them as much as possible.
So it's all about being proactive, right? Trying to anticipate those unpredictable scenarios that can trip up our tests. Are there any specific techniques we can use to make our tests more resistant to flakiness?
One key strategy is to choose your locators wisely. You want to avoid relying on brittle locators that are easily broken by minor changes in the web page structure. Instead, you want to opt for unique and stable locators like IDs or data attributes that are less likely to change frequently.
So it's like choosing a sturdy foundation for our tests,
Yeah.
something that won't crumble at the slightest tremor. Are there any other challenges we might encounter in our Selenium adventures?
Another common hurdle is dealing with elements that have complex structures or are deeply nested within the web page's hierarchy. Finding these elements with simple locators can be like trying to find a needle in a haystack.
So we need a way to pinpoint these elusive elements with precision, like a surgeon performing a delicate operation.
Exactly. And this is where XPath and CSS selectors truly shine. Their power and flexibility allow us to navigate even the most intricate web page structures and locate elements with laser-like accuracy.
Okay, so XPath and CSS selectors are like our secret weapons for tackling those tricky situations where simple locators just fall short. They give us the precision and control we need to automate even the most complex web interactions.
Precisely. And as you gain experience with Selenium, you'll develop an intuition for when to use each approach. It's all about, finding the right tool for the job.
This has been an incredible journey into the world of Selenium. We've covered so much ground, from basic automation to advanced techniques for handling dynamic elements, parallel testing,
Yeah.
and even strategies for overcoming those common challenges.
Yeah.
Before we wrap up, I have one final question. As our Selenium projects grow larger, more complex, how do we prevent them from becoming unmanageable?
That's a great question. As your automation suite expands, it's crucial to adopt strategies to manage complexity and ensure that your code remains clean, organized, and maintainable.
It's like keeping a tidy workspace, right? If everything is in its place, it's much easier to find what you need and avoid unnecessary chaos.
Exactly. One effective approach is to break down your code into modular units, creating reusable functions and components. Think of it like building with Lego blocks, You create small, self-contained units that can be combined and reused in different ways.
Ah, okay. So instead of having one massive script that does everything, we create smaller, more manageable modules that each perform a specific task. And this makes our code more adaptable and easier to update.
Precisely. Modularity is key to keeping your Selenium projects scalable and maintainable. And by following the best practices we've discussed today, you'll be well on your way to creating robust, efficient, and reliable Selenium scripts.
So we've explored all these ins and outs of Selenium, from basic setup to these advanced techniques for handling those dynamic elements and even parallel testing. I'm feeling pretty empowered. I could automate almost anything on the web.
That's the spirit. But before we wrap up our Selenium deep dive, I want to leave you with a thought-provoking question. We've talked a lot about the flexibility of Selenium, how you can customize it to fit, almost any testing scenario. But this flexibility also comes with a responsibility.
Ooh, okay. I'm intrigued. A little philosophical twist to end things. I like it.
So as you gain more experience with Selenium, you'll have the power to make choices, how to structure your code, what frameworks to use, how to integrate Selenium into your development workflow. And these choices can have a significant impact on the long-term maintainability and scalability of your automation solutions.
So it's not just about writing code, right? It's about making thoughtful decisions that align with our goals and the needs of our team.
Exactly. My challenge to you is this: as you continue your Selenium journey, think critically about the trade-offs involved in each decision. How can you leverage Selenium's flexibility to create solutions that are not only powerful but also maintainable, adaptable, and scalable?
Yeah, that's a great point. It's a reminder that automation isn't just about writing code. It's about designing systems that can evolve and grow with our needs.
And remember, this journey doesn't have to be a solo mission. The Selenium community is incredibly vibrant and supportive. There are forums, online groups, and even dedicated Slack channels where you can connect with other Selenium enthusiasts, ask questions, share your experiences, and learn from each other.
The power of community, right? It's amazing to have a network of fellow automators to lean on and learn from.
Absolutely. And don't forget, one of the most valuable resources is the official Selenium website. It's a treasure trove of documentation, tutorials, FAQs, and other helpful information.
And we've also talked about GitHub as a great source for finding Selenium projects, code samples and even complete frameworks that can serve as inspiration or building blocks for our own automation efforts.
Exactly. And of course, practice makes perfect. The more you use Selenium, the more comfortable you'll become with its intricacies, and the more confident you'll be in your automation abilities.
It's all about getting our hands dirty.
Yeah.
We're experimenting and learning from our mistakes.
Exactly. And remember, automation is not just about efficiency. It's also about improving the quality of your software and freeing up your time to focus on more creative and challenging tasks.
It's like having a team of tireless robots working behind the scenes, ensuring that our web applications are thoroughly tested and functioning flawlessly.
Exactly. And with the knowledge and resources we've discussed today, you're well equipped to embark on your own Selenium adventures. Remember, start small, practice consistently, embrace the community, and never stop learning.
Well, that concludes our Selenium deep dive. We hope you've enjoyed this journey into the world of web automation as much as we have. Remember, start small, practice consistently, embrace the community, and always stay curious. Happy automating.
Happy automating.
Until next time, deep divers.